Okay, hello everyone. Right now it's 10:37 in that night, and well, I spent all my morning to make that intro. If you ask me why, I don't know. I don't know why. Okay, let's continue with the project. Let's go to my folder, cd document, cd window project, open screen cap. Let's see. Yes, so far we have this one. Open the file, but I think I kind of want to group all of these into a function. Yeah, I want to group all these into a function, but before that, let me make sure that I don't miss anything. I think in the tutorial we have some more things that we can do. Wait, let me just turn off my okay. Yeah, I think I can go to visual at adding the tutorial. Go to the end of the pages and categorize it. Video player less than 1,000 likes. Okay, so far so good. Wait, just one more website. I think I can make this smaller. Yeah. FFmpeg example. Back example. Okay. Okay. I think my goal for today is try not to use ChatGPT to ask for answer. We try to research on what we have. Try to use all we have, storing the data, find video stream, AV dump format, open input, return red, find stream. So in the last one, I think we had the metadata, but what do we do next? I'm so lost because I didn't have so much energy left, but that's okay. Find stream info, yes. Iterate, metadata. Successfully open the video. Yeah, what do? We need to store the data. What about this one? What does this mean? First video stream. I think we have this one. Find a video stream, copy the context, copy codec. There's the codec. Wait, just want to make sure there's a codec. Do we have the codec when we print it? GCC. Let's try to compile it. String cap .c.o z2 okay, pkg config c flag library lib av format lib av codec lib sw scale lib av util. Oh, sorry, I think I got this one wrong. Lib av codec, yeah, to with the video we have. Creation time. I think it should be good. Store the data. Hey, metadata. Oh no, what do I do next? Oh, I'm so lost. What does the strand code mean? What does strand code? Oh wait, I think I can watch how someone else did it. View media player and see. I think I can go to the GitHub page. Yeah, this one right here. Go to the GitHub page. Yeah, I think I go to source code. Go to main, player CPU, util, basic audio player. Oh, no documentation. No. Oh, what do I do now? Find a decoder. Huh. Yeah. Oh, dumb format. Okay, as we try to follow all of this, we got the format. Yes, AV dictionary. Wait, what is AV dictionary entry? AV dictionary entry in Epic Impact. Yeah, there we go. No AI today. Jar AV dictionary. Oh, wait. I think it has it here. No, I think we can AV dictionary reference. Why do we have that? Include decodate. AV dictionary. Oh, it's a struct. It's going to allocate memory for the key for the value. Why do we need key? What does it mean? Why do we want key? Oh, get a dictionary ng with matching key. Why do we need that? Maybe dictionary key. Let's try to read it. Format key. Huh? What? So key. Oh, major brand ISO minor versions. Okay. I think let's do something else. Open the file. R2. Yes, find stream. Okay, we found the stream. We want to dump the format. Yeah, I think we can try it. Stream info. Okay, we can try to dump format. AV. Let's see if that function works for today. AV dump format. P format. V format. 0. AV dump format. Do we still have it? Impact. Oh wait. No, I think AV dump format. No, we don't have it. Where's the dump format? Impact to use AV dump format. AV dump format. No. Bring detailed information about the input and output format, such as duration, bitrate, stream, container, program, metadata, side data, and time error. Let's see if it still works today. 0 RV1, the name of the file. Also 0. What does it take, by the way? Index, URL, output. I don't understand. Oh wait, it's work. basic window, wait, basic window, oh, wait, it's working. Hey, I think this had more information than this while loop. Encoder, oh, wow. Huh. Okay, I think we don't need this. Bye bye dictionary iterate. It still works for some reason. Okay, so now we need a codec. Bye bye this one. I don't need this one. Wait, just to make sure it's work. Test 2 basic. Oh, okay. I think in summary, this one will give the information about the format, like the codec and all the things inside the container, like the encoder, the duration, the more detail, the bit metadata. Wow. Huh. Oh, even the bit rate, even the encoder. Wow, so it still works. Very cool. Now for my stream, just an array of pointer of the size. Walk to it until you find a video stream. Oh, walk to the video stream. Yeah, I think this should be a reference point. Yeah, let's go past this. Why we need I? No clue. But let's see. Now we need a pointer. We need a struct. AB codec contest. It's going to have the. Oh, no. Why do we? Oh wait. A new pointer. Wait, I don't know what if we use the same struct with another pointer. Same struct, add another pointer, add another pointer. What does it mean? Should I read this? To see on Reddit. I don't know, man. Format stream, just array of pointer. Oh. Offside, P format, and B streams. Oh, so we need this one P codec CT at. What does codec CT at? Origin. What is codec CT? What does CT at mean? What does codec CT at mean? Struct reference. Codec contest. Huh. Essential encoding decoding parameters for media streams such as width, height, sample rate, pixel format, and bit rate. It's a bridge between raw data packet and decode frame. Oh, I don't understand this. AV format, AV codec contest. No, wait. What's AV format contest? Wait, I think I read the wrong one. AV codec content. Oh wait, no, I read the wrong one. Sorry, I read the wrong one. Ah, wait, I'm back. AV codec contest. AV codec contest. Codec contest. AV codec contest. AV codec contest. Where is it? Where is it? Where's Omni-Man? Where is he? And that's meme. No AV codec contest. AV format. Oh, I read the wrong one. Sorry. Codec information from a stream, from AV stream to codec. So sample was AV code, AV rational, or codec information. AV codec content. B codec CTS content. Origin no. I wish I have a good teacher who can explain to me what does it do. B codec CTS equal no. Find the first video stream. I think do we have find a video stream? Decode. Send packet. No. Yeah, I don't understand it. No. Find the first stream. Wait, where did they get this from? Video stream equal -1. Is it missing an int? Are they? Yes, missing an int. Let's make an int. So we got a loop. Stream, video stream. Oh, I think it's more like decode video. Oh wait, what is the process of finding video stream card in impact? Dropping introspection. Stream selection. transcode. What is transcode? Convert input into output file. Now this one. Extract. What? Decode video stream. What is this one? Decode video. Decode and generate. Extract fhash. Remuse. Show metadata. Find video stream. Should I use this one? 2021? Yeah.
So Jonas, what are we launching today?
We gave cursor agents their own computers, and now they can test their changes and come back with a video recording of what they worked on.
In this quick tutorial, I'm going to show you how to extract different type of stream from a single video file or container format like MKV or MP4 or WebM. So let's say you have a MKV file which is containing a video file for sure and 2 or more audio stream in 2 different languages. Now you want to extract the video and different audio separately. So in that case, I'll show you how to do that. So here I am using a example.mkv file, and here I have 2 different audio. One is English and the one is Hindi, and I will extract the 2 different audio and the only video file separately. So to do that, I will use ffmpeg. I have already installed this on my computer and we'll use from the terminal. So this is the command. So if I explain the command,
No. Hey, wait, extract right here. Extract. Oh, I think this will be this one. That's true. That's true. Extract. Anyone help? Yeah, let's try it. It should be okay, estimate for I equals 0, I less than B format, CTS, and B stream. Then if P format point to the stream, I go to codec type equal AV media type video. Equal I break. Okay, if video stream equal -1, printf std didn't find a video stream with a negative one. Cool. Does it work? Okay, no, it does not work. No, I'm just have a wrong typing. Okay, no. No. Oh wait, I have a video here.
Hello, this is Steph. Today we're going to see the first tutorial of the series that we compiled the other time. So the other time we said how to configure the whole thing and how to work with this system. And little by little I'm fixing the tutorials. So there were the old versions, so now I'm updating to the newest version. So the updated FMPEG version that is going on in this period, 2024. And now we see the first tutorial of the series. So we start with the very basic things. So how to extract the frames and how to push them in a file. So we're going to see Ubuntu, Visual Studio Code, and now we can get started. Okay, so here we are on Visual Studio Code. And the first thing that we can do is to run the program. So to run the program, we need first to compile it, and here the configuration must be this thing. So in the Makefile tools, make sure that you have it installed. We saw this in the previous video. We have a
Previous video? Where did you get that? I think we need to watch the previous video. Wait, where did you get the previous video? And back.
Hello, this is Steph. Welcome back to my channel, and today we're going to see how to execute the programs that are in the, let's say, the most famous tutorial about FMPEG. This is the Dranger.com tutorial, and maybe you heard of it up to the F. In this video, thank you very much for all. If you didn't do it, and an FMPEG and STL tutorial, or how to write a video player in less than 1,000 lines of code. And it says that this tutorial is up to date as of February 2015. But
yeah, that's why the video.
So if you take a look at the guides, these are pretty straightforward. We're going to see them in one of the next videos, one by one. And if you pay attention at the code, so this is the original tutorial, but the updated version is available on GitHub. On GitHub, you have, if you're going to my repositories, I've cloned one of them, and so right here, let me increase the size, you will see that there are all the tutorials. I'm updating them little by little, so it takes a while because as you can see, these are pretty old. And some of them were updated, but not so much. So now we're going to see little by little how to update them. And this is the repository. I'm going to put in the video description later on.
Wow.
So at the moment, what is enough is to clone the repository, or if you want, fork and then apply your contributions. I will appreciate that if you do it. And then we are going to configure the FmpEg compiling and Visual Studio Code. Okay, so first of all, we're going to see how to compile FmpEg. This is nothing new. So this is something we saw both in my first video actually that I uploaded on YouTube, and also there is the script that is available here. So let's see it through Vim, FmpEg compile. Okay, here we go. And this is these are the commands. So first of all, the installation of the necessary material included libsdl2. So all the tutorials that are available. So the Ranger tutorial that we saw before used libsdl1 or 1.2. This is the most recent version 1 of libsdl. In this case, we're going to use libsdl2, and the tutorial is updated as well. So all the commands are available here. Maybe the only thing that we need to do is to take a look here and uncomment this make install. So this will make sure that all the executables and all the libraries are in the correct folder. So respectively, we have in the FmpEg build, we got bin include lib, share, well, it's not so necessary. So here you can compile both in the static way and in the dynamic way. So the important thing is that you have the libraries ready here in the libpkg. Then after you run the program, I've already done it, so it takes a lot of time. I also made the video upon this.
Yes, I think we know how to run the program. Yeah.
And I think that you need to do is to update the .bash rc, that is in the end, make sure there is this last command. So export pkg config path home and .bash rc. In the end, make sure there is this last command. So export pkg config path home FmpEg build pkg config, and use the previous pkg config path, because with this you are making the system aware there is this pkg config, so you can use it later in Visual Studio Code and whilst you are compiling using the make file. So there is a make file, so if you run make and the program you would like, everything will be compiled as it should. And I think that's it. We are ready to go to Visual Studio Code. Okay, so here we are. We are on Visual Studio Code, and here we have several choices here already loaded, I think myself. But if you want to clone the Git repository, it's something that you can do. You can do it via the command line. So as soon as we open Visual Studio Code, we open a folder. There is a terminal ready, so we can get git clone and the URL of the repository. But in this case, we can use the clone repository that is available there, and it's fine. So this is what you have in front as soon as you open the folder. There is something that is missing though for a very clean installation, a very clean compiling and a clean execution and debugging. Okay, so now make sure that you have the following things. So first of all, you need to have the ccpp properties.json. If you don't want to create a new file, you can right click on any of the C files and go to command palette, and here you can edit configuration using the JSON file. So here it goes directly to this folder. So here in the you need so the only thing you need to do on this file is to add this thing right here. So you will avoid
I think we will
and
try to skip this.
right here. So now I already have it, but here let's bin with in this case nothing
Oh,
requires
I think he's trying to help you to run this project, but yeah, I think you should
a
watch
file.
from it,
So it
but
requires
I think I can run it on my own, so I think I don't want to watch all of this.
your file to be
Let's try to skip straight to the code.
cell search deers. So that is not working properly. I've got to correct it. We'll correct it soon. The first is working fine, so it's going to be compiled. To get the project running, and if you want to debug, so a thing that you can do is to go directly into run and debug, and then make sure you are selecting the source that you are looking at, and then run right here. Don't use this because it is not working properly. Then now it's running.
It's running.
So here, the first thing we're going to see later that it generated the result correctly, and it's fine. So we are ready to rock and roll. Okay, so we finished with the configuration of Visual Studio. We are ready to execute the programs. We are ready to work with the examples that we have with ourselves.
Okay.
And what we need to do now is to take a look at the single files one by one, and so we can understand fully what does FFmpeg do to execute, to play our videos, our multimedia streams. So this is a very useful guide. A little bit dated, so for me it takes a while to update all the instructions. There are other modern ones around, but I guess this is a good tutorial to see in a very simple way, even with some mistakes, I got to say. But it's a good way to see how the program works. So thank you very much for reaching out to this point. If you didn't do it, please like, share, and subscribe, and hit the notification bell to get notified about the next videos I'll be.
Okay, let's go for this one.
Hello, this is Steph. Today we're going to see the first tutorial of the series that we compiled the other time. So the other time, the updated is to run the program. So to run the program, we need first to compile it. And here the configuration must be this thing. So in the Makefile tools, make sure that you have it installed. We saw this in the previous video. We have configuration, set it to default. Build target, at the moment we take the tutorial, tutorial 01. And launch target will be the tutorial 01. And the rest can remain like this. Then you click the button
Let's see.
right here to make the video, to make the program, and in the end you should have the executable ready to be run. So there might be some warnings, but don't worry about this. And right here you should have the window ready to be saying that everything went all fine.
Why is this so slow?
Okay, so here the process is finished, so we can go back and type a key to exit. And now what you can do within Visual Studio Code is to click on the Run and Debug. So here we have the configuration GDB launch, so we can launch the program. And I don't have any breakpoints, so the program should be executed as it is. And if you see, after a while, after the program is executed, so now the time that the debugger must run and everything.
Okay.
Okay, the program has exited. So we have 5 frames. So frame 1, frame 2, frame 3, frame 4, and frame 5. If we take a look at the frames individually, so here we don't see anything, but let's say these are the raw version of the first 5 frames that make up this video. So if we take a look at the folder where they have been saved, you will see that these are the first 5 frames. So let me open them with GIMP. Sorry that I'm in the virtual machine, so it's not the most performing thing ever. And here we go. This is the first frame. Then we have the second, the third, the fourth, and the fifth.
What is that thing?
Here we go.
What is that thing?
1, 2, 3, 4, 5. So difference is very subtle, but that's what it is. So the video doesn't change so much from frame to frame. And so this is it. Okay, so let's get started with the analysis of the source code of the tutorial 01. So we start with the inclusion of the libraries. So here we have AV codec to manage the stream, AV format to manage the containers, and SW scale. That's the thing that we're going to see later. It seems strange because it seems like that it's dealing with the scaling filter, but it doesn't work only on that point of view. We're going to see later. There's also STDIO, so the standard input and output, so to manage the messages that we want to give the user, just in case there were errors or everything was successful. And at the moment, there is also a function, say frame, we're going to see it later. That is the function to save the frames coming out of the video file and store them in the ppm file that we've just generated. So here we have the main with the usual argc and argv, with argc the number of parameters.
Yes, we have RC, RV.
And argv the parameters themselves. Here we say that if the length of argv is less than 2, so we need at least 2 parameters in the command line. We have a please provide a movie file, so everything like this. And here in the beginning, so for the people who work with FMPEG up to some years ago, up to version 4, I guess, we have the AV register all. What does the AV register all? This was the loading of all the list of codecs available. Now at the moment, since version 4, it is not needed. So this is now commented out only for didactic purposes. So in fact, not useful anymore since version 4. Now, first of all, we're going to open the file. We have the P format context, that is this AV format context that it needs to be allocated with the proper function.
Oh, so it's not no. He need to allocate with the proper function. Alloc content.
And it cannot be allocated. There's an error message. So
I think it's a good practice to check for a failing of allocation. P format context. If the pointer is no, F printf. I learned this. My professor only tell me to do this. Yeah. Thanks, Mr. Torres. Could not allocate Professor Torres memory for format context. Return access failure. Always check for success or failure of allocation of allocation of memory. Good practice. Yes, good practice to check for the allocation of the memory. Okay, so we open. Oh yeah, I think we should move it to the top. Very first thing we need to check is if we have the enough argument. Yep, check for enough argument. Retrieve information. I think we need red. What does red mean? What does this one return?
I'm going to summarize that there's an error message as soon as this is going to fail. And also, since this procedure will be adopted with all the things we're going to do later, so I don't want to repeat the things so much. Otherwise, so the video is boring by itself. I don't want to get it more boring. And so we have, after that, after the allocation of the context, we have the open file. So this will open the file directly and will open the file with the path that we have in the first command line, the second command line. And it will load everything in the format context. Then,
okay, what does this one return? I think we want to figure that out. AV format, open input, demusing. Oh, so let's call demusing. AV format, open input. Read media file split into chunks of data packet. Oh, so let's call demusing. AV format close input. Return a void. AV format open input. Yes. Or return an int. Why is this return an int? What do we need with that? Why do we return an int open? AV format open input. So we got a context. Yes. Got a file name, input fmt, we got option, parameters, the pointers, to user supply reformat. Yes, file name. If not, no parameter forced to specify input command. Option dictional field with. Yes. Success negative. On failure. Oh. I think we don't need this because it's returned an integer to indicate if it can open a file. So I think yeah, I think you're gonna follow his example. We don't need to store a return value. I don't know if it will helpful or not, but I think we will try to store a return value. Return red. Do we want red? I think we don't want to, but let's let's try to rewrite this one. We only need to call a function. Opening the file. Opening the file. If call the function av format open input. We access to the pointer p format. The link to the file of v1 and the fmt optional. I think it's optional, right? Yeah, it's not a parameter forced to specify input format. I think we don't want to specify input format, so we get it to no. Dictionary field ab context and the user private option. So this parameter will be destroyed and replace with dict containing option. Maybe no. For now we get no because we don't know what it does. Yeah, if this one return 1. Oh, is it one? If this one fails, going to return 1. F bin F std couldn't open the file. Return exit failure. So if it return -1, it return a negative number, so it's going to could not open the file. Oh, and I think this one also return an int.
We're going to retrieve the stream information. So we're going to see what we're going to deal with.
Oh wait, why do some function return in? Why do some function in C return in? That can indicate true or false. Why do some? This language history lack of native Boolean type. 0 a false. Oh wait, 0 is a false. 0 is success. Wait, so if it returns 0, so this thing is success. No, it is for false. So it could not open the input. Huh? What? I don't get it. Why? What does that mean? Why is written n, right? If we use it with f, should be at ChatGPT. No, we don't want to ask him. Let's just have some faith in him. Okay, so we want to retrieve information. Retrieve stream information. Yes, let's just have a little bit of faith in him. Okay, if AV format find stream info p format no less than 0. Huh? Wait, can I go back a little bit?
We're going to see.
Oh, it's not equal 0. Oh wait, I think we can do red. In success, indicate equals 0. Oh, it's not 0, so it will be uh, a false. Oh, so I was wrong. I'm sorry. So we need to specify it. So we can use red. Yeah, we can use red. If red equal wait, if success indicate oh, I think I will explain why we use this. If I use this in an if with a function, that function will return an int to indicate like something. Yeah, I think. Oh, so that's why success indicate is not equal 0. So if so if it's not equal 0, like a negative, it will be wrong. So and it cannot open a file. So if it returns 0, so it's be a success. Wow. That's cool. Success indicate equal yes. Hey, what does this function do? Find stream, av find stream info. Also return an int. Oh, greater or equal 0 is okay. Error is error. So is it 1 less than 0? So f win f std couldn't. Yeah, I think this will be a bad comment, but I think it's kind of self-explanatory, but I think it will be helpful later. Yes, so couldn't find stream information. Oh, his tutorial is very clear. Thank you, DevStep. Thank you very much. Thank you. You saved me. Couldn't. Did I write C or what? Couldn't find stream information. Yes, information. Return access failure. Oh wow.
Which so what we're going to deal with, and we are going to check the codec and the parameter. The codec.
AVDump. Oh, I think we will keep with the AVDump format. Yeah, I think we will keep the AVDump format. Okay. Yeah. The information about file onto standard error. Yeah, I think we will try that. Good enough. That's good enough. I think we will make this one at a reference point that we made it. Hehe. Okay. So we need AV codec. Okay, so we need the next thing is we need AV codec.
Codec parameters, and the codec we're going to deal with, and we are going to check the codec and the parameter. The codec and the codec parameters. And
we need to check the codec and the codec parameters. Okay. AV codec, P codec equal no, AV codec parameters, meters with an S, right? Parameters with an S, P codec parameters, codec param equal no, and find the video stream. Find video stream. Equal -1, not found, negative -1 is not found, mean not found. We need I? Why do we need I?
The codec and the codec parameters are taken out from all the streams available in the format context. So we might have a video with audio and or video, multiple videos and multiple audio. In this case, we select the first video stream.
The first video stream.
Case we have in fact a video stream that is set to -1. That is a value that is not wanted. In fact, there is the escape right here. And we have the codec parameters that are loaded in this piece of code. So we are giving the video stream as soon as it is found out with the proper index that is in this for loop among all the streams available. And we get the codec parameters out of the format context. So we have the stream and the codec parameters with this field codec par. The P codec, it is retrieved using the codec ID in the codec parameters, and we have this AV find decoder that will retrieve the real codec that we want to use. As soon as something is found, it will break the loop, and so we're going on to the next step. And
okay,
the real codec that we want to use.
Okay, so we need to write a for loop to scan through the video. We need to scan through the file to find the video stream. Scan through the file to find the first video stream and use it. Yeah, for I in I equals 0. Oh, he used in here, so we don't, he don't want to type in right here. Oh well. I is less than p format c content nb stream. Wait, what is nb stream? What is nb stream? What is nb stream? Back nb stream. No, I don't want to use AI. Yeah, no AI for today. We have a good teacher already. Wait, here, oh here, nb stream. nb stream. What does nb stream mean? nb chapter. Wait, let me have some break. Oh man, my eye. Oh, it's an hour already. Oh wow. What is end? Oh wait, here nb stream is an end. It's represent a nb stream is a number of element in AV format context stream. AV format constant stream, list of all stream in the file. Oh, so this stream we have, so list of all stream. So in the video we will have a multiple stream. How many streams are in a video? Why do a video have multiple streams? Oh, so basically, I think inside the video there's many streams. We have audio stream, video stream, metadata, subtitle, and the video stream will be the first one. Which will be the very first one. So if we encounter a video stream, so if p format, so as we scan through the file, if we find the first stream, copa, codec type, not sure if my knowledge is correct, maybe it's wrong, equal AV media type video, AV media type video. If we, so for all this, if we find the very first stream and it is AV media type video. Wait, what does AV media type video in impact? Media type video numerator. Oh, it is an enum. So media type video, it is an enum. Return the string defined media type. It's an enum. So, wow. Oh. Return the string defined media type enum. I think this enum will indicate that one is the video stream, and that means that we've found it. We found it. Video stream equal I p codec parent and equal p format cts. You go to stream, codec par. I wish he had more comment on what each line of code does, because this library is really big. Go AV codec, find decoder, p codec, parent, codec ID, yeah, correct. only me. We only the first video stream. There's a normal video file only has one video stream at the first stream. Oh, only contain one video stream. Oh, that's why we need to scan through the file. If we find the first video stream indicated by an enum, then yeah, that should be our video stream. Maybe we will have more than one video stream. Oh, so that's why. Huh. And check if video stream equal -1. Didn't find a video stream. Return access failure. Yeah.
As soon as something is found, it will break the loop. And so we're going on to the next step.
Yes.
And the next step is to allocate to get a pointer to the codec context. Before we had the format context, now we have the codec context, and we have this method, we have this function.
Get pointer to the codec context. What is a codec context? What is the codec context? Codec context. Codec context in the web and back. What is the codec context? Codec option. Why do we need a codec context? Encoder decoder. Yeah, I think we can add AI for this. I think it's gonna help us. Codec context will present the AV codec structure to manage encoding and decoding a single media stream. Oh, store essential bitrate, frame size. Okay, hit a pointer. So the next thing we want to do is get a pointer to the codec context for the video stream. Do I understand it? No, I'm not. AV codec context. The codec CTS codec context equal AV codec allocate context. So we allocate context 3. Oh wait. Oh, so they have their own function to allocate memory. To allocate memory for the codec. Wow. Wait, why the P codec? Oh, we can use. We don't have to allocate memory by manually. They have a function for it. So if P codec CDS equal no, so with the error std couldn't allocate video, couldn't allocate memory for video codec context. Return exit failure. Wait, AV format, AV Allocate AV codec, allocate context. What? Wait. What? Why did he use that? AV format context. Why? AV format context. It's kind of inconsistent here. Why did he have the wrong one? AV format context. AV codec. AV format context. AV format. Reference. Oh, I don't know. Yeah. So we allocate for that memory.
Have this AV find decode. You take the parameters to the
Fill the context. Fill the codec context from the codec parameter value. Fill the codec. From the codec parameter. If AV codec parameters to context p codec CTS, passing the this pointer to here, p codec param less than 0, std able to copy codec param to codec context. Failure. Yeah.
context. So we're going to fill the codec context with the parameters that we found earlier. We have these AV codec parameters to context, p codec context with p codec parameters that we had before. And now finally we can open the stream. So we have AV codec open to with p codec context and
We need to open the stream.
p codec with the escape error. Just
Open to p codec CTS, p codec, no, less than 0, f and f. Fail to open codec. Is the message failed?
this thing doesn't work. The escape error. Just finally you can open the stream. So we have AV codec open to with p codec context and p codec with the escape error, just in case this thing doesn't work.
Open the stream.
Now we have the format that is retrieved. We have the codec that is retrieved. We have the parameters, so we know how to open the stream. We know how to get out the frames. So now we're going to allocate a video frame. And here we have this AV frame.
Allocate video frame. Oh, so we need to allocate video frame. Okay. Video frame. AV frame
with this AV frame,
alloc.
with the allocation of the frame. And
Okay, so we need a a struct, right? AV frame. Wait, I think what is AV frame? AV frame. What is AV frame? So AV frame is a struct that that contain what? AV frame is struct to contain the data, the line size, point to the picture channel, extend data, sample, and a lot of things. Oh, it's a struct. Okay. So we need AV frame, P frame equal AV frame, AV frame alloc. So need to allocate memory for it. If AV frame P frame equal null, we cannot allocate memory. So we print the error message. std couldn't allocate memory for video frame. Yes. Return access failure via packet.
then we have the packet. The packet is like so a piece, let's say, of a frame that needed to be taken out of the stream in order to populate the frame itself.
Oh, we need a packet. AV packet. P packet. Wait, yeah, I think they explain it in here. Packet. Why do we need a packet? Go to the entire video stream. Packet we code into our frame. Convert it and let's save it. Packet. A struct in raw packet data is stored. It should be given to get a frame. Oh. AV packet alloc if P packet fail to allocate memory basic std couldn't allocate memory for AV packet. This is failed.
Now, this is the input frame. The one that we have after p frame RGB is the output frame. So we're going to take the input into the output. So we take from the video file the frame, that is p frame, and then we are going to save what we have in p frame into the p frame RGB.
Oh. I don't know what this means. Allocate an AV frame structure. AV frame P frame RGB equal AV frame alloc if P frame RGB equal null. So we're gonna print f to too fast typing. Couldn't allocate memory for output video frame. This is failure. Huh.
So we allocated the same way we had before. So AV frame alloc, same method. And here we have this SWS context. So this is the scale context. Usually it is done for filtering. Here, what we're going to do is a simple color space conversion, because by default, we have the data that come as YUV or so YCBCR. And we want as output the RGB. So we pass from YCBCR, YUV, into RGB. Here we set the number of frames to
Oh, okay. I still don't understand it, but let's trust him. WS contest CTS equal SWS get contest. P codec CTS. So we go to the width. P codec CTS. We go to the height. P codec CTS. Pixel FNT. P codec CTS. Let's go to the width again. Oh, it's no, should be the comma. Or should be the column. Why is width again? Codec CTS height again. For some reason. AV pit FNT RGB 24, another one, BT BI bilinear, no. Oh wow.
RGB. Here we set the number of frames to process. So the numbers of frames to process.
He want to process 5 frames. Yeah, I think we will follow him. To process equal 5.
Is equal to 5. If you want to change it, you can. So I want to take only the first 5 frames as it was in the original tutorial. So if you want to change this number, you are free to do it. And then we are resetting the loop to 0, because this will be used in this internal loop that while we read frames, in this case it is a while, then we are going to break after if it is when it finished.
Wait, just I will stop recording for a sec. I will be back. Hi everyone. I'm back. I just talked to my mom, brushed my teeth, and yeah, I think I'm pretty in a good condition, a little bit better to continue with this. Okay, in I equals 0. So we gonna reframe and say first 5 frame 5 frame to the disk while AV reframe B format B packet equals 0 and wait, and I less than frame to process is this a packet from the video stream? If P packet stream index equal video stream decode video frame if AV codec send packet P codec CTS codec context P packet less than 0 F printf std error y sending packet to decoder I think we should have a new line. Return exit fader. Okay.
We have this AV read frame with this format context M packet. So you need these two parameters to take out the frame. And here we have the limit, the break limit. So if we are before the frames to process, we can go on. Otherwise, we stop. So here we take out a packet out of the video file, and we say, is this about the stream we are looking at? So the stream index is belonging to the video we are looking at. If it is, we go on. Otherwise, we don't do anything. So we're going to decode the video frame with this method. In this case, this is the new thing that is in this in FMPEG AV codec send packet, and then later there is the receive frame. So there is this passing of a packet from one way, the input to the.
Wait, let me check the battery. Sorry, everyone. Okay.
Sorry. There's a passing from like server and client. So we have the send and receive from the input and the output. Then here, okay, these are all error management.
So we have the in frame finish frame finish equal 1. Did we get a video frame while frame finish when equal 0 and oh, so after we finish this one, if this one is correct and no error, we have one frame already. Yeah, I think we have one frame ready. I less than frame to process. Finish process. frame finish equal AV codec. VC frame P codec. Context P frame. Okay, these two return value. How special I mean? How special? D2 return value. D2 return value. Value are special and mean there is no output available, but there was no error during decoding. And if frame finish equal AV error E again, AV error, or frame finish equal AV error EOF and a file. So we are going to break else if frame finish less than 0, f finf std error during decoding. Okay, wait, let me go to the new line. Assist failure. Return assist failure.
Here, okay, these are all error management. And so if we have the full finished frame, so here we are composing the frame until we have the full frame. So if we have a full frame, that is because the frame finished variable that is right here is not with a value that is below 0, or it is not of this kind, AV error or end of file, we are going on making up the frame. Once the frame is made up, once the frame is fully composed, we are going to allocate the output frame. So we're going to allocate it.
Oh, we got to allocate the output frame. Oh, okay. And if we have a frame, AV image alloc P frame RGB data P frame RGB line size P codec context width P codec context height
Using the data that are in, so these are the input and the size. Let's say line size is how many rows we have. So how many with the height of the video, basically. And here we have the data as output and also the size as output, as we can say. Then we have the size as width and height coming out from the codec. So this is the input, and which is the color space we want to use.
and the color space AV pixel AV pix FNT RGB 24. All is less than 0, so it means there's an error. Makes sense. std could not allocate output frame, couldn't allocate memory for output frame. Ethernet failure.
So here we use
Convert frame to its native format RGB.
the conversion. So this is the process of conversion between the input, that is YCBCR, YUV, into RGB, and this is the process of conversion. So here now we have the frames from the YCBCR into the
Yeah.
RGB. And then in the RGB, we take this frame in RGB, and we're going to save the frame. So we go up to the function that we had in the beginning, that we skipped before. And here we are going to open an output stream with a file name that is being decided by the this thing. So here we're going to take the name of the frame based on the counter that we have. In this case, it is the counter plus 1. So it is 1, 2, 3, 4, 5, no, 0, 1, 2, 3, 4. We open the file, and just in case there's an error, we're going to get out with an error. And here we put the header of the ppm file. The ppm file requires a p6. So in other sites you see p5. It depends if you have a color frame or grayscale frame. If it is a color frame, you have it with the p6 in the beginning. If you have grayscale p5, color p6. In this case, we want it in color, so it is p6, with width and height and values that are up to 255, the values that we are expecting. After, we are going to write the pixel data. So as soon as we have the data inside, so here we have the data put as stripes. As you can see, so we're going with the height, and we're going to put line by line all these bytes, and in the end we close the file. As soon as all the frames are done, we are going to unreference and remove and free all the memory dedicated to all the things that we used. So we open all the here we have
Okay. Convert
so here we
to its native format. From its native format. Oh, we're not done yet. Convert the image from its native format to RGB. AWS scale. AWS context CDS. P frame data. P frame line size. P frame wait 0 P codec CTS height P frame RGB data P frame RGB line size and this one. Save the file to this. Save the file to this. I think we should make a function first.
use the the convert.
Yeah, the conversion, say frame, p frame, RGB, p codec, codec context, width, p codec, CTS, height, plus I. Oh wow, look at that.
So this is the process of conversion between the input, that is YCBCR, YUV, into RGB, and this is the process of conversion. So here now we have the frames from the YCBCR into the RGB. And then in the RGB, we take this frame in RGB, and we're going to save the frame. So we go up to the function that we had in the beginning, that we skipped before.
Yeah, he made a function. Now let's try to make it. Void save frame, which return nothing. AV frame, P frame, the width, in the height, in the iframe. Let's see. It says let's make a file, P file, chart, C file name, 32. Yeah, I think he don't want to be the size, the name way too big, so let's, all he should do, open the file as printf, file name, frame, %d dot ppm, iframe. Wait, I think I want to write into a directory, so mkdir frame. Yeah, I want to write in here. S winf in C, swinf string print, store is Java first. Content string, store into buffer instead of printing on SDL. Oh, I see. Just this one's for the name only. Okay. P file equal app open, file name, WB. Wait, what is? How to write into a file inside a directory in C. Open. Oh. Ah, I see. File name. Can I? double backslash. Does this really work? Does it? Write to file. Oh, your folder. Ah, I see, I see. I think it's called frame. Yes, with an S. Frame. Frame. And this one with does it really work? Does it really work? Should I add ChatGPT about this? No, I don't want to. Yeah, I think I can ask just one. I think it's no. I think it's the good to use to it. Hey, I want to write to a file inside a directory. Is this code correct? It is not quite. Oh, well, that's charming. 256. Oh, that's charming. That. Thanks a lot. Yeah, that's all I need. Okay. And wait, what is FB? WB in app open. WP write binary. Oh, write binary. Translation. Oh, I see. And if p file equal to no, std cannot open file, return. Write headers, fprintf, p file, p6, so for the color, and %d, %d, that and %d, and width 255. Why 255?
Here we are going to open an output stream with a file name that is being decided by the this thing. So here we're going to take the name of the frame based on the counter that we have. In this case, it is the counter +1. So it is 1, 2, 3, 4, 5, no 0, 1, 2, 3, 4. We open the file, and just in case there's an error, we're going to get out with an error. And here we put the header of the ppm file. The ppm file requires a p6. So in other sites you see p5. It depends if you have a color frame or grayscale frame. If it is a color frame, you have it with the p6 in the beginning. If you have grayscale P5, color P6. In this case, we want it in color, so it is P6, with width and height and values that are up to 255, the values that we are expecting. After, we are going to write the pixel data.
Right, pixel data. The pixel data for int y equals 0, y less than height, y plus plus.
So as
F, right? Never heard of this function before. I never learned it. Frame data 0 plus I multiply p frame line sign 0. Oh, what? Width multiply by 3 in p file. What? Close the file. Ah. Oh man.
we have the data inside. So here we have the data put as stripes. As you can see, so we're going with the height, and we're going to put line by line all these bytes. And in the end, we close the file.
Line by line.
As all the frames are done, we are going to unreference and remove and free all the memory dedicated to all the things that we used. So we open all the memory that all the frames are done.
Wait, why don't we have two? Okay. Free the packet. Get that was allocated by AV frame AV packet unwrap p packet.
We are going to unreference and remove and free all the memory dedicated to all the things that we used. So we open the packet and we close it. We close the context, we close the input and the output frame.
SWS free content SWSCTS free the YUV frame AV frame free the address p frame frame free free frame RGB and close the codec, AV codec. Contest P codec CTS, close the video file, AV format, close input. Oh wait, I think I only have it. Yeah.
Close the codec and we close the format. So this is a good manner to avoid memory leaks all around. And then we return to 0. So this is the basic way to work with FFmpeg. The rest will be built up upon this knowledge that we did. So I hope in the next...
Okay. Yeah. Huh? Wait. It's a good thing that we only have 9 warning and 7 error. Oh, line number 8. Oh, sorry. My bad. Oh. Typo. Codec bar 71. Oh, sorry. Missing with a C. '74. P codec. '123. I think we ignore the errors real quick. 123. Incompatible pointer. An expression. Huh? Oh wait, let me go to his GitHub real quick. To his repository. Yeah, let's go to the tutorial 1. I think it's the struct get contest. Oh wait, I get the wrong one. Oh well. 74 P codec. 74 P codec. AV find decoder. AV codec find decoder. Param codec ID. Yes, kind of correct. What else? '144 AV codec send packet. 144. Oh wait, wrong function, sorry. AV codec send packet. AV image analog. AV image. Wait. AV image. Oh, I think I got the wrong function. AV. When finished. AV image analog. What? Yeah, that's kinda correct. It's 171. Oh man. Oh. Oh no. No. Oh man. 174. Let's see if this fits it. One error. P-frame data. AV image. AV image analog. Wait. FFmpeg AV image analog. What? Did I miss something? No. Oh, what? Why though? 174. P-frame data. Did he use it? Undecided ton. AV image analog. Wait, did he write the same thing as me? Yeah. What? Huh? What? Huh? AV image analog. util. I have to specify the library. Oh, where do I get the AV image outlook? Oh yeah, let's check the library. cd edit impact, cd lib, AV util, image. Oh, my ear hurt. Image outlook. Header file. Yeah, thanks AI. emg util.8. Oh yeah, so now it should work. Okay, or maybe not. Still not. Oh, to view argument. To view argument. I need one more argument. Hey, where's the code? Somewhere in here. Oh, in here. Tutorial C. Image alloc. 1. Oh yeah, 1. Was missing 1. What was that image say? What's the last image copy? View array. Sorry. An int align. Oh, okay. Clear. Okay. 2. Basic. Cannot open file. Oh, so there's an error here. Cannot open file. Oh, cannot open file. Oh, sorry. Yeah, sorry. Oops, my bad. Test 2. Basic. No. How about like this? Sorry. Is yeah, that's why we need this one. All the error check is super helpful. Oh, what? Really? It's work? Oh, thank you.
We don't get so much in detail with all the things that we've done in this first tutorial, but we see the differences between this piece of code and what we're going to see next. Okay, so we reached at the end of this first tutorial. The next time I'm going to see the second and so on with all the others. And we're going to see the differences between what is in this and the next. And so if you reached up to this point, thank you very much. And please like, share, and subscribe, and hit the notification bell to get notified about the next videos I'll be releasing. And for the moment, I greet you. And so please stay tuned for other videos regarding multimedia, but also much, much, much more. Ciao! Ciao!
Wait, did he say in Vietnamese?
Tune for other videos regarding multimedia, but also much, much, much more. Ciao! Ciao!
So much. Did you just say hello in Vietnamese? That's so cool. Oh, okay. Yeah. After a long time to copy the code, we finally make it extract all the frame. Wow. That is this is a long process, but yeah, let's see what we did. I think I will try to summarize it, but I don't understand all of it. So first of all, we need to have all the library, especially this one. We check for command line argument, make sure that we have 2, and we use a struct to have all the metadata, and we open the file. We see the stream information. We dump the information into the standard error, and we find a video stream. And if we don't find it, we exit the program. We need a codec context. Okay, from now on I don't understand this. I think I need someone to explain it. I think I will ask my professor. I think he know it. Yeah. So yeah, I think that's how you open a file and you extract the frame. I think we have like five frames. CD document. Oh, sorry. CD window project. CD frame. Yeah, we got 5 frames for the video. This video right here. Oh well. Why is it so it's not complicated, but I just don't understand how it works at a low level. That's why it feels very complicated, but in fact it is not. Well, in fact it is not complicated. If you understand the low level detail, then everything about it should be pretty clear. But because we don't have the general idea about how it works, that's why it looks kind of scary. Yes, it looks kind of scary to me. I don't know why is it that way, but can we get rid of the all the error? Assigning AV codec. What does this really mean? Let's fix the error really quick. Warning, assigning to AV codec, aka struct, from const AV codec. Discard qualifier. What? P codec. Hey. What? Passing unit in jar to parameters type const b frame data. What does that mean? AW scale const frame data. B frame data. Assigning codec to AV codec from I think you have to add a debugger flag. I think we can try to debug it. How to B frame data. Context C. SOC slide. SW. Oh wait. Wait. FF impact SWS scale SW scale SW scale SW scale lip scale SW scale. What does that mean? Author. Oh no. SW scale. Is this true? Yeah, that's the correct name. Array a pointer to image plane. Array a pointer to image plane. Frame data. Then how do we fix that? Color conversion and scaling. Color conversion and scaling. FF impact example. Wait, let me just oh, scale video. I think this should have an answer in here. Pass video size, get context, image alloc, data line size. Okay, create scaling context. Oh, okay. Convert the image from native to RGB. Reference point. Wait, What is error? P codec. Fast video size. Convert destination format. Cons. Wait, instead of data, can we use bframe? Source data. Where did he get the source data? Source data. So this is a process of software engineering. Oh wow, it's so painful. But wait, passing unit in to parameter. Oh, what? Oh wow. Oh. Oh, I'm sorry. I think I lamenting way too much. I think I'm whining way too much. Sorry. Data line size. What is unit in? Wait. What is unit in constant pointer to constant data? Is this low level thing? It's not even that low. Oh, not even the image allocate. Frame finish. Demusing. Wait. Demusing. Decode video. Copy codec. Find decoder. I think. Oh, I see it. Oh, so this I got the answer for here. Got the answer. Static in. Retrieve information. Open codec contest. Wait. Open this. I think we got problem at yeah. Find a stream. Receive stream information. How do they find a stream in here? We see the stream. Yes, find the stream. Find stream info. Allocate. Dump format. Yes. Yes, yes. Oh well, not here. How did they find the stream? Open codec contest. Decode packet. No, not here. Dump information. I think they have the while loop somewhere. They have to find a stream. Could not open. We see stream information. Could not open the source. Oh, here, read it. They find a stream in this line of code. They open the codec contest. They open codec contest, audio stream. 0 audio stream. Huh? No. I think that's not. Huh? If audio stream. Oh, they use open codec contest. They don't use the for loop. They use open codec contest. Do we have it? Do we use it in here? Oh. Ow, my neck. Oh, my neck hurt. Oh, my neck hurt. Nope, they don't. We didn't use in this example. Okay, I think we can try to copy them. Let's see. Okay. Open codec contest. Demuting. Yeah, that's right. AV frame, sample, AV sample format, VC stream. Oh, wait, here. Oh, right here. Use video stream. Ah, right here. We don't have to use a while loop. We don't have to use a while loop. We can use We can use AV codec contest. Okay. Okay. I think we will use go to N. Oh, I think they combine the step. Oh, I think for this step right here, they kind of combine it with the say the frame. Is that true? I think we don't want to do it. Oh, okay. This big chunks of code right here. Yike. Okay. Find a stream. If open codec contest. I think this should be enough for today. Let's try to finish this one and we go to sleep. Video stream. Video stream IDS. Video stack. Wait, do we need to specify that? Video deck. CTS contest. AV media. Oh, so yeah, I guess watching his video really helpful because he helped me get the basic of what is happening, and from that reference I was able to figure it out how to do. Thank you very much. Super duper appreciate that. Type video equal 0 and video stream go fmt cts stream video stream IDS. Allocate. Wait, does this really work? Oh no, that's not it. Oh no. Open codec contest. Wait, I think I forgot some library. ffmpeg open codec contest. Codec contest. Codec contest library. Div AV format, yeah, that's right. AV format. I think I did something wrong. Stream IDS. Video stream IDS. Did I miss that? In Yeah. Oh, static in. Oh. Oh, okay. Let's try it this way. Static in video stream IDS equal -1. Nah. Oh well. Video deck CTS. Oh wait, did I miss something? Video stream. Oh, sorry. I think I got that wrong. I think I got that wrong. Video stream. Video stream IDS. Wait, did that reduce the error? Yeah, a lot of error. Let's see how much error do we have left. Undeclared function, open codec contest. Open codec contest. Where is it? Video deck CTS. Video decks. Oh, I think I missed a library. Include lib avutil sample fmt .8. Still not. Video deck CTS. Video deck CTS. Right here. Static codec content. Oh wait. Wait. I think I had that. Codec contest, right? I don't know what I'm doing. Video deck CTS equal no. Okay. So that should clear one more error. Okay. FMT CTS. FMT CTS. Wait, where's the main function? FMT CTS. Warning 2 error. Static AV format. Oh, it's right here. Static AV format. Oh, sorry, I forgot. Static AV format. AV format contest. CTS equal no. Open video stream. Ah, you have to manually do it. Open codec contest. Oh, what? Oh, I'm sweat. Okay, I need one more function. And I will go to sleep. I will go to sleep. Static in open codec content in stream IDS AV codec contest deck CTS AV format contest FMT CTS enum AV media type media AV media type okay in red stream index. Oh well. Let's go for static. Yeah, let's go for static. AV stream SD cons AV codec deck equal no red equal AV file the stream. Oh, there can be multiple streams. CTS type -1 -1 no 0 if res less than 0 f printf std couldn't find stream in input file. And AV get media type string see wait file name Okay. So the file name, it should be our yeah, it should be our file name should be rv1, should be rv1, yeah, it should be rv1, it should be rv1, rv1 return red. What does that mean? I don't know. Else stream index equal red, st equal nts cds stream index find decoder for the stream. Oh, okay, so it's going to check multiple things. Check equal AV codec. Oh, so for the example, he can simplify. Oh, I think on the video, I think he really simplify the process down to the maximum, so we can understand it. But in here, there's a variable coder st codec par codec id if not dec. I don't know why not dec. Happen std to find codec. Av get media string type return av error eval. Huh? Allocate codec context for the decoder. I think we don't need that. I think we don't need that because we already did that from the beginning. Return 0. Stream ID equals stream index. Stream index. Oh, it's my bad. Sorry. Oh, wait. That has even more error. field argument. Open codec, media type. Oh, two field argument. Wait, let me just FMCTS, video stream IDS, FMCTS, NTCTS, content. No, not this one. Yes, that's error. Oh, I think they didn't recognize that. Source file. Where did they get that? I know they have a case here, but when did they pass into the function? Wait. MCTS. Wait, what is a video stream? I think they have video stream in here. Video stream. Now that makes sense. Constant jar. Static. Then jar. File name. Equal no. Okay. Let's see if that's correct. Then file name equal one. And just one more error, which is the video stream, static AV video stream, or static AV stream, static wait, what is AV stream structure? What does it contain? Yes, another error. Okay, so I cannot use this int. I cannot use this int. Oh, let's take it out. Static AV stream. Okay. Just one more condition, and this should be done. Video stream. If not, didn't find a video stream in the input power. Existing. Okay. No. Oh, my bad. Sorry, I didn't fix that. Jump by 170. Oh, 170. Oh, I think they kind of messed up the structure. Oh, I think that's a simple fix here. How about with the stream IDs? Wait. What about I use that one here? Is that a video stream, right? FMT CTS stream video stream IDs. Pointer. What if I differentiate it? Wait, in this example, what is that the video stream equal to? Video stream. Okay, clear. Invalid in the AV stream. pointer and an integer. So video stream is an int. Wait, video stream is an if streaming that. Packet stream. Packet stream in that. Does this really work? Wait. AB stream. Rational index. Oh wait, got this. Got it. Index. What about this one? Wait, it work? Does it? It work? Wait. CD. Huh. To basic. Oh no, segmentation false. Oh well. Here we go again. Oh, okay. I think I should give up. Yeah, this is too much. Segmentation false. Hey, LLDB. Hey, I think it's time to use LLDB. Debug the flag in the flag in C. Oh, okay. Find best stream. Oh, find best stream. Find best stream. So the error is this right here. Find my stream. Oh, okay. There's segmentation false here. Find best stream. Where's stream index? Stream SD. Okay, sorry. Did I missing something? Oh yeah. Oh, I see. You're right. Open the file. AV format. Okay. Hiểu rồi. Ok. Ok, hiểu rồi. Static. No B format contest. Instead of this, we use B format. B format contest. Okay, that's going to use B format contest. Use B format contest. Okay. And what does that call? Alloc something. AV frame, AV AV format alloc. Do I need? Wait, what is that function called? AV format alloc context. Okay. No, still segmentation false. Okay. Good allocate memory for format content. Ok, thử lại coi. No, it's still error. Okay, yeah. Yeah, still segmentation for. Run, allow. AV codec parameter to context. AV codec parameter to context. Pointer to codec context. Video deck CTS. Yeah, I think I messed up the code. CTS. Yeah, I think I messed up. Okay, I guess I messed up the code. Let's see the useful command. Control Shift L. Commands. Wait. Okay. Select this one. Text CTS. Oh. Okay. Oh, okay. It's kind of late, so let's try to do it tomorrow. Hey, thanks for watching. Yeah, that's like 3 hours. Bye, everyone. It's 2:30 in the morning. Yeah, I'm just tired. Maybe fix it tomorrow. Okay, cool. Bye.